last class we have covered what is arithmetic mean, what is geometric mean, and yeah, let's do a few more questions based on the same logic.
We haven't finished the last one.
Yeah, can you please repeat?
We haven't finished the last one.
Okay, we haven't finished the last one. Oh yeah, I said to you that today also I'll be starting the class with the same. Yeah, thanks for reminding me. So we were supposed to find, just a moment. This is the question. Find the value of n. Find the value of n so that this may be the geometric mean between A and B. Okay, we are supposed to find the value of n so that this, whatever is written in the question, that is the geometric mean between A and B. And we say that between A and B, geometric mean will be geometric mean according to formula. Geometric mean formula was B square was is equals to root AC. AC is the left end number, right end number multiplied together inside a root. That was geometric mean, right?
Yes, ma'am.
Okay, so if we are having the left number as a and the right number as a B, and if we are talking about what will be the geometric mean, that means root AB, right?
Yes, ma'am.
So according to us, geometric mean was root AB, and according to the question, this is the geometric mean written in the question. We did the comparison. And then we are trying to find the value of n. We are trying to use the method of factorization so that anything can get cancelled over here at least. Okay, if we will be able to simplify it, then only we will be able to proceed. But even if we are observing it carefully, I think the if you can see the right hand side, just see carefully the right hand side over here. Just keep on looking at this right hand side. Whatever you will do, any simplification is not possible. If you are trying to take out anything common from the numerator, nothing is possible. A to the power n plus 1, one thing is coming in our mind, that a to the power n plus 1 can be written as a to the power n into a to the power 1. Yes or no?
Yes, ma'am.
Okay, even though we will write our a to the power n plus 1 this way and b to the power n plus 1 this way, still no simplification is possible. Okay, so after realizing it, we didn't have any choice. What we did the multiplication of the denominator from here. From here we took the denominator and we multiplied over here. So distributive property, how we will do the multiplication? Root AB over there will get multiplied with a to the power n plus b to the power n. Okay, this is the multiplication. This is the multiplication which you can see here directly. Are you able to relate with it?
Yes, ma'am.
Root AB multiplied with a to the power n, then root AB multiplied with b to the power n. That's what we have done over here. So far, any confusion?
No, ma'am.
Okay, then still we are thinking now what to do. Now what to do? Still we are not getting anything over here. No common, nothing. Okay, nothing at all. Okay, just now you have done the multiplication by using distributive property. This one you multiplied and this one you multiplied, so definitely common we will not take, right?
Yes, ma'am.
Okay, same step, why we will repeat again and again. Just now we have done the multiplication of root AB with a to the power n plus b to the power n, so which you can see over here and you can see over here. So of course we are not going to take out common. Okay, so now we are thinking then what to do. So we realize that if we can take this a to the power n, see carefully, a to the power n, with a to the power n from here, because that a to the power n plus 1, initially we realize that that is nothing but a to the power n into a to the power 1, right? So
Yes,
we
ma'am.
are writing this two term together. Why? Maybe we can do factorization. Maybe. Okay, we are just taking them together. And this term, this b to the power n, this one, we are keeping with that one. Why we are doing so? Maybe we will be able to do factorization. That's why. Making sense?
Yes, ma'am.
Okay, now we are proceeding. Now we are proceeding. And what we are realizing over here in the next step, after keeping them together, okay, this a to the power n root ab with a to the power n plus 1, you can see in the next step we have written a to the power n plus 1 as a to the power n into a to the power 1. Why? So that we can do the factorization the way you used to do splitting the middle term, and after doing splitting the middle term, how beautifully you used to get the same bracket. Okay, here also we are expecting that anyhow if we can get taking common from here, taking common from there, and in case we will be getting the same bracket, then maybe we will be able to solve from there. So we took the common factor c, a to the power n, root ab we have written as root a into root b, and a to the power n plus 1 we have written as a to the power n into a to the power 1. I'm just going to take the common factor, but we need to realize that here something else is common. In class 10, have you done in quadratic equation chapter such question where you were doing factorization and square root term were involved over there? For example, we are having 2 root 3 minus 3, here x square, here x, and I am just asking what can be taken out as a common factor. What can be taken out as a common factor from here? So x can be taken out common factor, and what else? So are you realizing that 2 root 3 x square, okay, will be 2 into root 3 into x, and the other one 3x can be written as 3 into x, but this 3 into x still we can write as a root 3 into root 3 into x, and this we used to do only when there is a square root term, the same root is there in the other factorization. Have you done something like this previously?
Yes, ma'am.
Common is this one, and what else? X. Remaining is 2 over here, x over here. Remaining, if we will take root 3x common, remaining is 2x over there, 2x over there. And here what is remaining? Just root 3 over here. Getting it?
Yes, ma'am.
Everyone, is it making sense? If it is making sense, then only we can use the same logic, exactly the same logic over here. Over here we can say that a to the power n root ab can be taken as root a into root b, and a to the power n into a can be taken as root a into root a. Why? Because we want to take the common factor properly. Okay, just focus on the left side first, automatically you will understand the right side, because same thing we are performing over there. So the left side is a to the power n root a root b, and here a to the power n root a root a. One more step I have shown. Okay, even if I'm not showing this step directly writing this one, still you need to understand that we have taken a to the power n common and root a common. Making sense?
Yes, ma'am.
And same thing we have done on the other side. There b to the power n was common and root b was common, and can you see both side we are getting the remaining bracket term exactly same, exactly same,
Yes, ma'am.
and hence we cancel them out. Now what are we left with? We are just left with a to the power n root a and b to the power n root b. Now we are thinking now what to do with this a to the power n root a and b to the power n root b, what to do over here. So we are thinking, let's add the powers. Law of exponent says that when the bases are same, then you can add the power. Since no simplification is possible now, so we have just written them in compact form. Previously we were breaking them just to take out common factor, just to do the simplification, but now all the simplification is done. We don't have any scope because here a, there b, we don't have any scope now. So what we can do, we can write a to the power n root a as a to the power n plus 1 by 2. Can you see that, this
Yes.
one? How we will understand we have to do these many things over here? Yes, the moment you will start doing, you need to think in this manner. First, any simplification possible? No. Crisscross multiplication, simplify the fraction. Denominator from here will go to other side. Then any simplification possible? No. Just open the bracket and use distributive property. Now just see any simplification, anything is possible. So maybe we can take the pair together and we can do the factorization. Okay, we are doing a to the power n, a to the power n, we are keeping them together, b to the power n, b to the power n, we are keeping them together, and coincidentally we are able to cancel out the bracket term, and we are left with these two circles. Okay, now we can say that this two can be written in the ratio form because both the powers are same, both the powers are same. So we can say, we can write it as a to the power, actually we can write it as a to the power n plus 1 by 2 by b to the power n plus 1 by 2, that is equals to 1. Getting it?
Yes.
Okay, and directly we can write it as this one because law of exponent says that if the power is same, then you can write a by b and whole having power 1 n plus 1 by 2. That's what we have written in this particular step. Can you see?
Yes.
Till here, any doubt? Anyone having any doubt so far?
Uh-huh.
Okay. Next, we need to find the value of n over here. N value. And clearly we can see our n is sitting in the exponent. That is the power over here. We have not learned any method to just find the value from, okay, to from the power. We just know when exponential equation we are having, when 2 to the power x, when 2 to the power x is equals to 2 to the power 32, then we can say x is 32, right?
Yes.
Okay, since the bases are same, exponent will be same. So we are trying to think about that what can be done with this one. So we realize that 1 can be written as a by b to the power 0. Are you getting it?
Yes.
We are writing them just to compare the power because we don't know any other way to take out the value of n. It's not like that there are so many ways and this is one of them. No, this is the only way to solve it, to compare the exponent. Is it possible over here? Yes, it is possible. Why not to use it? Okay, a by b to the power 0 we can write 1. Now we can say comparing exponent on both side, n plus 1 by 2 is 0, hence n is minus 1 by 2. Getting it?
Yes.
Is it clear to all of you? What are we discussing over here? Geometric progression? Yes, but basically, mainly we are discussing calculation over here, simplification over here. Once you are comfortable with the exponents and simplification, you this chapter will be easier for you. And yeah, the exponent and simplification, these type of scenario you are seeing maybe for the first time. Clear? So
Yes.
after this class, you need to do it by yourself from starting till ending to check have you understood or not, because the statement is straightforward that in between A and B, geometric progression, geometric mean is this one. Hence, find n. According to us, geometric mean, according to question, geometric mean. Now we just need to think about solving the obtained equation. Anyone having any doubts so far?
No, ma'am.
Let's move. Now the next question is, if arithmetic mean and geometric mean of roots of a quadratic equation are 8 and 5 respectively, then obtain the quadratic equation. If arithmetic mean and geometric mean of roots of quadratic equation are 8 and 5, then obtain quadratic equation. So let's try understanding the question first. Arithmetic mean, geometric mean we are having of what? Roots. So suppose you are having a quadratic equation ax square plus bx plus c. Okay, and root of this quadratic equation, suppose alpha and beta are the roots. Okay, now arithmetic mean and geometric mean of roots, that means alpha, beta. In between that arithmetic mean we can generate. Okay, and alpha, beta in between geometric mean we can generate. Yes or no?
Yes, ma'am.
Okay, this arithmetic mean and geometric mean are given as a 8 and 5. Read it. If arithmetic mean and geometric mean of roots of quadratic equation, that means the left end number is just a root of quadratic equation and the right end number is nothing but just a root of quadratic equation. In between that there is arithmetic mean, that is 8, and the same roots is creating GP, and in between that there is geometric mean, that is 5. Making sense?
Yes, ma'am.
Then obtain the quadratic equation. Then we are supposed to find the quadratic equation. As you know, the moment we will be able to take out alpha and beta, we will be able to frame the equation, right? In class 10 polynomial chapter was teaching you how to make a polynomial when the roots are given, right?
Yes, ma'am.
Okay, so the moment we will be able to find alpha, the moment we will be able to find beta, then finding quadratic equation is not a big deal, right?
Yes, ma'am.
Okay, let's try. So alpha and beta are the roots, and in between that arithmetic mean is 8. So can we write arithmetic mean is equals to alpha plus beta by 2? Can we? We know
Yes, ma'am.
arithmetic mean is left end number plus right end number divided by 2. That's how we were discussing arithmetic mean in last class, that if we are taking two number 2 and 4, in between that we can introduce a number so that all three will maintain AP, and the middle number is called as arithmetic mean. How we were finding? We were taking the left end number plus right end number divided by 2, right?
Yes, ma'am.
Okay, so we can write it this way. Now arithmetic mean is given to us as a 8, that is alpha plus beta by 2. From here we are able to say that alpha plus beta is 8, 2 times 16. Equation number 1 is clear to all of you?
Yes, ma'am.
Next, this alpha and beta is also creating GP. Is that even possible? Of course that is possible. We have such a magical formula that we can, with the same two number we can create a AP, with the same two number we can create a GP, right?
Yes, ma'am.
Okay, so if our left end number is 2, right end number is 4, then we can introduce a number in between so that all three will maintain GP. How? By using the formula under root 2 into 4, that is root 8. Even though it is in root, it is completely fine. We can write this root 8 as a 2 root 2. Okay, root 8 means 2 into 2 into 2. That means 2 root 2, right?
Yes, ma'am.
Okay, so you can see these 2 root 8 and 4, or maybe 2 root 2 and 4, these all three are in GP. Okay, so with the same two number we can create AP, we can create GP. There are formulas. We are going to use the same logic, that alpha and beta is there and the geometric mean is 5. Formula for geometric mean is, geometric mean formula is under root alpha beta. Yes or no?
Yes, ma'am.
Geometric mean is given to us as a 5, that is root alpha beta. That means alpha beta is 5 square, that means 25. Can you see equation number 2?
Yes, ma'am.
Now we have equation number 1, we have equation number 2. Why we will solve them? Sum of the root and product of the root is there. Let's create a polynomial, quadratic polynomial. What was the formula? X square minus sum of the roots into x plus product of the root. That was the formula for creating the quadratic formula, right?
Yes, ma'am.
Already we know the sum of the roots is 16. So x square minus 16x. Product of the root is 25 plus 25 is equals to 0. We can just give it a name. It's just a quadratic equation, because quadratic polynomial and quadratic equation, these two chapter, we are having so many similarity, and these are not completely different topic. These are related topic, right?
Yes, ma'am.
Is it clear to all of you?
Yes, ma'am.
No? Let's check the statement. If arithmetic mean and geometric mean of roots of quadratic equation are 8 and 5 respectively, then obtain the quadratic equation. Making sense? Everyone getting it?
Yes, ma'am. Yes.
Okay, it's very simple. If you want to recheck, you can recheck. After finding the roots, you can check that 8 you are getting as arithmetic mean or not. Okay, 5 you are getting geometric mean or not. You can check it. After finding the roots from here, alpha and beta values from here, yeah, you can check it. If you want, you can check it later. Now we can do another question. If A and G, B arithmetic mean and geometric mean respectively between two positive numbers, prove that numbers are A plus minus under root A plus G, A minus G. Okay, let's read the question carefully. After reading the question, you may think that, okay, what is given over here, but please read it carefully. You will get it. Just a moment. So if A and G be arithmetic mean and geometric mean respectively between two positive number, you have two positive number. Okay, two positive number. One time you are getting the arithmetic mean, capital A. Another time you are thinking about GP and you are getting the geometric mean as a capital G. Okay, you are representing the geometric mean by capital G. Okay, so suppose two positive number we are assuming as a x and y. Suppose I have taken one of the positive number as a x, another positive number as a y. When we are talking about arithmetic mean, then these all three are in AP. Okay, A is the arithmetic mean, and the next time we are talking about the same two positive number, and this time the geometric mean is capital G. So we can write the formula for arithmetic mean. What was the formula? The left end number plus right end number divided by 2. So we can write capital A is equals to x plus y by 2. Yes or no?
Yes, ma'am.
And we can write capital G is equals to root xy. Same thing we are doing in almost all the questions, right?
Yes, ma'am.
Okay, now what we will do? We will try finding the two positive number. That means x and y. How? By creating the equation x plus y is equals to 2a and xy is equals to squaring both sides z square, right?
Yes, ma'am.
Okay, now we have two equation. You want to use identity from class 9 or whatever, you can use it. Otherwise, if you are not getting anything, then you can take the method of substitution. You can take x value from there. Suppose you are taking x value from here. You are saying that x is nothing but 2a minus 5, and this x we are going to substitute in the second equation, which you have learned in pair of linear equation, and then you were using in quadratic equation chapter also. So we are having g square is equals to xy, and you have taken x is nothing but 2a minus 5. X is nothing but 2a minus y. Why over here? What is the motto? What is the purpose? The purpose is to find the x value and y value. Even though we don't have numbers, still we will try finding the x and y. Making sense?
Yes,
So what are we getting? G square is equals to 2ay minus y square. Here G, capital A, these all are just like a constant for us. These all are just constant. We'll be writing y square minus 2ay plus z square is equals to 0. Yes, splitting the middle term, we are not able to think about that. But when we will use quadratic formula, when we don't know anything, quadratic formula is the savior. Let's use that. Okay, y value we will be getting by using quadratic formula. That is minus b. That is minus of minus 2a. Are you understanding your b is minus 2a, or you are getting confused?
ma'am.
Getting it? Your c is capital G square. Getting it?
Yes, ma'am.
Okay, so minus b. Now I will write plus minus. Okay, under root b square. Minus 2a whole square will be 4a square. Minus 4ac. 4a is 1. Here the variable is y. A is 1 and c is capital G square. So can I write 4g square
Yes,
divided by 2a? A is 1. Let's find the y value. We will be having y is equals to just 2a plus minus. Now in the bracket, you can see 4 over here, 4 over there. Let's take out 4 common. Let's take out this 4 common. We'll be having a square minus g square over 2. From the root, we can take out 4 out, but 2 will come out, right?
yes, ma'am.
Okay, so we will be having 2a, we will be having plus minus 2 will come out in square root. We are just left with a square minus g square over 2. Now you can take 2 common from the numerator, and the denominators to numerators 2 will cancel out each other, and your y is looking like this. Your y is a plus minus under root a square minus g square, which can be written as a plus minus under root in one bracket a plus z, in another bracket a minus z. Getting it?
Yes, ma'am.
It was really simple. We have just written the arithmetic mean and geometric mean, and hence we ended up getting a quadratic equation. Our focus was on finding the x and y, and we got y as this one. Now we will try finding x. Okay, we have two options. We can substitute this y in any one of the equation to take out x, or maybe we can, if that way it is okay, it is confusing, or maybe not, we are not that clear how to put y, then we can start from the beginning and we can make a quadratic equation in terms of x and we can solve them. Okay, so let me check whether finding substituting y is easy or difficult. Can you see first? Let's get back to our question. If you are thinking that, let's match with the question, that whatever we are having in hand so far, is it matching or not? Let's match it. Then you will realize that we are completely right. Okay, on the right, we are on right track. Can you see? Prove that the numbers are this. Can you see why we have already obtained like
Yes, ma'am.
this? And yes, we have not done so many simplifications and all. Easily we got y as a this one, right?
Yes, ma'am.
Okay, if you want, you can substitute your y over here in equation number 1. If you will substitute your y, let me show you what can be done. You can see the equation number 1 is here. Your equation number 1 is giving you x is 2a minus y, right? X is 2a minus y, right?
Yes, ma'am.
Okay, let's substitute it. If you are thinking why I'm separating left side, right side, I'm just trying to say you have two different values of y, because plus minus sign is there, right?
Yes.
Okay, and the quadratic formula has already taught you that plus minus sign means one of the value is containing the positive sign, another is containing the negative sign. Okay, so we are having a plus, I'm just taking this one for y, one of the values a plus under root a square minus g square, and another y is a minus under root a square minus g square. Making sense?
Yes, ma'am.
These are the two y, and we are not doing anything for the first time. Okay, we have done this thing previously as well. We will drop this y in equation number 1. 2a, x is equals to 2a minus y. Y is this. 2a minus a minus root. 2a minus a is just a minus this root. Making sense?
Yes, ma'am.
Next one, when y we will drop in equation number 1, x will be 2a minus y. Let's write it in a bracket. 2a minus a plus root. We cannot do anything with this root, so we have to copy paste. And we got two x values. Can you see that?
Yes.
And both the x value, can we write them together as x equals to a plus minus, one is plus sign, another is minus sign, under root a square minus g square? Yes or no?
Yes, ma'am.
Okay, which can be written further as in bracket, in one bracket a plus g, in another bracket a minus g. X can be written as a plus minus. You write minus plus, you write plus minus. Okay, nobody will tell you that no, it is not correct. If you are thinking that why not we are writing minus plus, yes, you can write it. But in general, in its standard form, we write it plus minus. Okay, just this way we in general we represent it in root a plus g and a minus g. Is it clear to all of you?
Yes, ma'am.
It was really simple. Two positive numbers we are having. In between that, arithmetic mean is capital A, geometric mean is capital G. Hence, find the two positive numbers. What we did, capital A is equals to left hand number plus right hand number divided by 2. Then another equation we are getting, geometric mean G is equals to square root of left number into right number. Then there we are doing squaring. Here we are just taking this 2 to the other side. We are just simplifying the equation to take out x and y value. And we got our x and y value. This is what we were supposed to prove. Any doubt?
No, ma'am.
Okay. Next. Before taking the next question, I want to introduce something over here. Just a moment. Can I say 6 by 8 is nothing but 3 by 4? Can I?
Yes, ma'am.
Okay, 6 by 8 is nothing but 3 by 4. If you are thinking why I've written like that, please cancel it. You will be getting 2 3 times 6, 2 4 times 8. 3 by 4. Okay, now there is a rule called componendo and dividendo rule. Okay, that rule says that if you will just 6 plus 8 if you will do, and the same 6 minus 8 you will do. Similarly, if you will do 3 plus 4 and 3 minus 4 over here, you are gonna get 14 over here, and 6 minus 8 is minus 2 over here. And here you will be getting 7 by minus 1. Can you tell me, is it valid? Is it true or false?
Two,
False. Left side, right side are not equal.
two,
Okay, it is true. Here clearly we can see the left side and the right side is still matching. Previously it was matching, then we did something. We don't know what exactly we started doing, but the last step is valid at least, right?
yes, ma'am.
Okay, so this method is called componendo and dividendo method, where we will be taking the, okay, we will be taking the numerator's number and then we will add denominator to that, and the same numerator we will subtract denominator to that. Is it making any difference? But the condition is you have to do it on the both side. If you are doing only on the left side, then it will not be valid. This is not acceptable. If you are doing this componendo dividendo on the left side, you are bound to do it on the right side. Let's take few more example and let's just convince ourselves that yeah, it is working always. So maybe if we are having 12 by 16, for 3 times 12, for 4 times 16. If you are thinking that why I'm taking again 3 by 4, 3 by 4, so let me take you another fraction. Suppose we are having 9 by 18, which is same as 1 by 2, right?
Yes, ma'am.
If we will add the denominator in the numerator and if we will subtract the denominator from the same numerator, I'm not changing the sequence. Numerator first, added denominator. Numerator first, subtracted denominator. But I am bound to do the same thing on the other side. If I am not doing, then both side will not be same. And this mathematics will reject it, that this is not allowed, not allowed. So we will be doing the same thing on the other side, added and subtracted. Here we are getting 27 and there we are getting minus 9. And there we are getting 3 and there we are getting minus 1. Is it still true? Is it true?
Yes. Yes, ma'am.
So now maybe we are convinced that when we are performing this type of simplification, then our fraction is not changing. The only condition is we have to do it on both sides. Okay, we have to do it on both sides. Now if we will encounter why we are learning this process, so that we can deal with, if we are having x plus 1, if we are having x minus 1 is equals to 5, then x equals to, you are thinking that we can do it by doing crisscross multiplication, and I am telling you yes, you can do it by doing crisscross multiplication. But let's try this method, which is telling you whatever numerator is there, just add denominator in that, and whatever numerator is there, just subtract the same denominator. And same thing you are bound to perform on the other side, otherwise you are doing it using this okay, this concept very incorrectly. So we are bound to do the same thing on the other side, and this way we are not doing any changes, we are not doing any changes, we are just doing one arrangement. Okay, still both side will be same. Okay, so equation we are not disturbing. As I always say, equation is just like a seesaw, both side is maintained. Here 50 kg person, here 50 kg person. If you are subtracting 2 from here, you are bound to subtract 2 from here, so that you are not disturbing the equation. So here we are not disturbing the equation, right?
Yes, ma'am.
Numerator will be x plus x 2x, and minus 1 plus 1 gone, minus 1 plus 1 gone. If you will open the bracket, you will realize. And the denominator x plus 1 minus x plus 1. So can you see x x gone? And what are we having? We are having plus 1, that is just 2. Yes or no?
Yes.
Okay, 5 plus 1 6, 5 minus 1 4, 2 2 gone. And how beautifully we got the x value. Can you see that?
Yes, ma'am.
What if we will solve our way, which we have learned from very lower class, that do crisscross multiplication? Yes, you can do so. You will be getting x plus 1 is equals to 5x minus 5. That means you will be getting 5x minus x is equals to 1 plus 5. That means 4x is equals to 6. That means x is 6 by 4. Can you see both? The value is not changing. Getting it?
Yes, ma'am.
Okay, then why we are learning this method? If both are acceptable and if we are able to use our way, then why? What's the need to use a new method so that you can deal with this scenario? Now it is not that simple. Can you see? And we will use componendo and dividendo. What we will do, we will, whatever numerator we are having, we will add the denominator with that, and whatever numerator we are having, we will subtract the denominator. So the numerator I am copy pasting, and we will add the denominator. Now you must be getting idea when to use this thing. The same numerator minus the same denominator. But we are not allowed to do only on one side. Okay, we are bound to do on both sides. So let's do it on both sides. That side we are having just 9. 9 means 9 by 1. So we will be doing 9 plus 1 by 9 minus 1. Any confusion so far? Have we disturbed the equilibrium? No. Any confusion so far? Anyone?
No, ma'am.
Okay, then we will open the bracket in the numerator. What are we going to get? This time we will open it. Okay, this time we will open it carefully because so many terms are involved. Chances of getting confused is more over here. So we are going to open it. Plus, nothing will change. This gone, right? 3x plus 4 plus root 3x minus 5 minus root 3x plus 4 plus root 3x minus 5. This gone. And what are we left with? 10 by 8. Now let's see what are we having in the numerator and what is there in the denominator. Can we combine them or something? So root 3x plus 4, root 3x plus 4. We can write 2 root 3x plus 4, right? Similarly, root 3x minus 5, root 3x minus 5 added together is 2 root 3x minus 5. And that is equals to 10 by 8, which can be written as 2 5 times 10 to 4 times 8. 2 gone. Can you see it became really simple? Previously, it was quite difficult. Now we can do crisscross and we can do just squaring both sides. And believe me, the moment you will do squaring both sides, still it is really simple. Yes, this 4 will become 16, but this will be just 3x plus 4. And that 5 will be 25, but that will be just 3x minus 5. Can you see the equation which was really difficult? If you could have done the crisscross multiplication initially only, it will contain so many terms. And even you will do squaring here, squaring there, easily all the term will not cancel out. Are you understanding why we are discussing this concept over here?
Yes, ma'am.
Okay, for solving this type of situation. So let's take a question where maybe we need to use this particular logic. So the question says that the sum of two numbers is 6 times their geometric mean. Show that the numbers are in ratio 3 plus 2 root 2, ratio 3 minus 2 root 2. Let's see what the question says. Okay, the sum of two numbers is 6 times their geometric mean. So actually you are having two number and their geometric mean will be root xy. Yes or no?
Yes, ma'am.
Okay, the sum of two number, that means the sum of x plus 5 is is means is equals to 6 times their geometric mean. That means 6 root xy. Making sense? According to question, this is what given to us. Yes or no?
Yes, ma'am.
Okay, and we have to find the ratio between x and y. Ratio between x and y. Now just observe this one. Observe this one. If you will do squaring both sides, here you will be getting x square, here you will be getting y square, here you will be getting 2xy. And there just 36xy. Now you will be having x square plus y square is equals to 36xy minus 2xy. Maximum you can do, that means 34xy. And after this, are we able to find the ratio? No. Is it solvable? No. Do we have another equation? No. Then what we will do? Then maybe we need to think about identity. Okay, x plus y we are having. Let's try using the identity of x minus y. Identity you have learned in class 9, that is x plus y whole square is x square plus 2xy plus y square, and the other identity was x minus y whole square is x square minus 2xy plus y square. These two identity you have used so many times, right?
Yes, ma'am.
Right. So if we will use this identity, maybe we are using the first identity, the first one, to take out x square y square. Let's check what can be done. The first identity, if we are using, we don't know what to do, so we are thinking about using the first identity, or maybe we are thinking about doing squaring over here. Squaring both sides will give you x square. Just now we were doing squaring and we realize also we were getting x square plus y square as a 34xy. Yes or no?
Yes, ma'am.
Okay, just now we did squaring and there only I told you that we cannot do anything from here. I mean the ratio we cannot find from here. Let's use this x square y square value in the second identity, so that in case if we will generate x minus y is this one as a equation number 2, then maybe we can work with equation 1 and equation 2. Pair of linear equation we have learned, right? X plus y we are having. In case if we can find x minus y by using the identity, then maybe pair of linear equation, that concept will help over here to take out x and y. The moment we are able to take out x and y, then we can find the ratio between x and y. Making sense?
Yes, ma'am.
Okay, so we are just going to use the identity. The second identity, x square y square, we will be substituting from equation number 1. You can call it for now equation number 2, okay, which we got from 1. So we know second identity says that x minus y whole square is equals to x square minus 2xy plus y square. We know x square plus y square is 34xy minus 2xy. That is 32xy. Any confusion so far?
No, ma'am.
Okay.
Ma'am,
And what are we getting? From here, we are going to get x
ma'am,
minus. Yes.
isn't it 36?
Yes. Can you please repeat?
X square plus y square, isn't it 36 xy?
No, that is not 36. Okay. That is one step I have skipped. X plus y whole square is equals to 36xy. And then whole square, we have used the formula that
Okay.
yes, whenever you are getting confused, please ask. Because if I am skipping this step and if it is not making sense, then from here only confusion will start and it will remain throughout. Okay, so please do ask anywhere if anyone is not getting from where I have written a certain step or a particular step. Okay, so this is what we are getting. There we are using the formula and we are getting this one. And then we are saying x square plus y square is 36xy minus 2xy. That means 34xy. And that we are using in the second case. Anyone having any confusion so far? Forget about these two identity. You already know it. It is registered in your mind. So I don't need to write these identities, right?
Yes, ma'am.
So far, anyone, any confusion? No. So 34xy minus 2xy is 32xy. That means x minus y is root this root 32xy. Yes or no? Right?
Yes, ma'am.
Please check From the given x plus y, 6 root xy, we did the squaring both sides and we got x square plus y square as a 34xy. Now that one we are using in the second identity, x minus y whole square formula. Why we are doing so? Why we are doing so? So that x plus y is given, maybe we will be able to take out x minus y, then we can solve both the equation. That's why we are doing so. Okay. So now you can see you are having equation number 3. Now focus on equation 1 and equation 3. Equation 1 and equation 3. I'm writing it for you, okay, separately, so that you can focus on equation 1 and equation 3. Your equation 1, which was given to you, that sum of two number is 6 times their geometric mean. It was given to you and you have written the equation number 1. And equation 3 you got from the identity that x minus y is root 32xy. Let me simplify root 32. 32 means 2 to the power 5. 2 into 2 into 2 into 2 into 2. Okay. That means one pair, another pair. I can say it is 4 root 2 xy. Yes or no?
Yes.
Any confusion so far?
No, ma'am.
Now we are about to solve this two equation by the method of elimination. But are you realizing what about the other side, root xy? We won't be able to find the value of x or maybe y, right? Even if we will add this two equation or we will subtract, it is not possible to find the x value or y value. Are you realizing that?
Yes.
Why? Because the right hand side is not a number. Even though right hand side will be just a square root number, that is also acceptable. But root xy and there also root xy, it is not possible for us to solve now also. After doing this much, giving this much of effort, still we are not able to solve it. Now, as you know, when you are having two equations, you are allowed to add those two equations. Pair of linear equation have taught you that two equation can be added, can be subtracted. I'm telling you, two equation can be multiplied also. You can multiply left hand side with left hand side and right hand side with right hand side. And two equation can be divided also. You can divide left hand side with left hand side and right hand side with right hand side. So we are thinking, what if we will do the division between two equation and then we will use componendo and dividendo? Are you getting it?
Yes.
Okay, because till now, like just now, we have seen two example from componendo and dividendo, and division was like this only. The numerator was something, denominator was the same thing, but with different sign, right?
Yes.
Okay, for this particular reason, I started teaching you that yes, we can sit for the whole day and we can find a way to solve it, and that way will take completely maybe 1 hour 2 hour for solving. And there is a easier way to, why not to use easier way to solve it, that is using componendo and dividendo. But at first we need to divide this two equation. Just a moment. Yes, before proceeding from here, anyone having any doubt, please tell me. Aisha, Manvi, Mariam, Nabila, Neha, any confusion?
No, ma'am.
Okay, let's move. We will divide 1 divided by 2. Okay, not 2, 3. This is 3. So we will be having, you can see your equation number 1. Dividing two equation is allowed? Of course it is allowed. The way we can add them, similarly we can divide them also. Okay, just we need to divide left hand side with left hand side and right hand side with right hand side. By doing so, you can see what are we getting. The denominator root 2 xy, I am going to separate it. That means root 2 I will be writing separately and root xy I will be writing separately, so that I will get rid of this xy, which was the problematic situation for us. Making sense?
Yes.
Okay, now we are thinking that let's use componendo and dividendo. What does it says? It says that just take your numerator and add the denominator. Okay, here we will write in between. We are using componendo and dividendo, but for now, let's apply it first. So the numerator added with the denominator, and the numerator subtracted with the denominator. It's not mandatory that here you have to add only. Here you have to add only. Here you can do subtraction also. But the same thing you have to perform on the other side as well. And here you can add also, but the same thing, same sequence you need to follow on the other side as well, so that your equality sign that is getting maintained. Making sense?
Yes.
Okay, so x plus y plus the denominator, x plus y minus the denominator. On the other side we need to do the same things carefully. So 6 plus 4 root 2 by 6 minus 4 root 2. Any confusion so far?
Um,
Let's see what will be the numerator. Here the numerator will become x plus y plus x minus y. So y gone, x plus y plus x minus y gone, and the denominator x plus y minus x plus y is equals to, we can take 2 common from numerator and denominator, because 6 is there, 4 is there, so 2 can be taken out common. So 2 we will take out common, and there we will be having 3 plus 2 root 2, and here 2 common, 3 minus 2 root 2. Here the numerator is 2x and the denominator is 2y. We thought that we will be getting x, then we will be getting y, and then we will be finding the ratio. But after doing this one, we are realizing that already ratio we are having in hand. Can you see that?
yes.
Let's match it with the given proof. 3 plus 2 root 2 by 3 minus 2 root 2. X by y is 3 plus 2 root 2 by 3 minus 2 root 2. This is what we were supposed to prove in the question. The sum of two number is 6 times their geometric mean. Show that the numbers are in ratio. 3 plus 2 root 2, 3 minus 2 root 2. That's what we have obtained. Yes or no?
Yes.
Again, I'm reminding what the question says over here. So the question says the sum of two number is 6 times their geometric mean. The sum of two number is 6 times their geometric mean. We have done so many questions, and every time we were able to solve. Why? Because that time we were talking about geometric mean, arithmetic mean, both. And hence we were getting two equation. But this time we just have one equation. And we are just thinking and thinking and thinking, and we are not getting anything how to solve it for x and y. Then we thought that let's use the identities. So first we are doing is squaring over here, which is giving us x plus y whole square is equals to 36xy. That means x square plus 2xy. Just a moment, no. So This is what we were getting. X plus y whole square is 36xy. Then we need to use the formula x square plus 2xy plus y square. That is 36xy. There xy, here xy. We are thinking let's keep them together. So x square plus y square is 36xy minus 2xy. That means 34xy. Now we are thinking this one we are having in hand. Let's use the other identity. That means x minus y whole square formula. So x minus y whole square formula is x square minus 2xy plus y square. There we are using this x square plus y square. That is 34xy. X square plus y square is 34xy minus 2xy. That is 32xy. So we ended up getting that x minus y whole square is 32xy. That means x minus y is root 32xy in root. Clear so far?
Yes, ma'am.
We have x plus y in hand. We have x minus y in hand. The moment we are seeing this two equation, we are happier. But again, we are struggling. We are thinking that, but what to do with the RHS part? We could have applied the method of elimination, but this RHS, this is creating the problem. If here 6 root xy is there, there also root 6, I mean 6 root xy, the same 6 root xy will be there. Then also we can subtract the two equation and the RHS will be 0. But that is also not happening. If you will subtract 1 minus 2, RHS will not be 0. Getting it?
Yes, ma'am.
So we are not getting any idea what to do after this one. So we are using the componendo and dividendo, but before that we are dividing this two equation. Always this componendo and dividendo we use in this type of situation only, where the numerator denominator term looks same but with different sign. One is having positive sign, another, just like in numerator you are having a plus b, denominator is a minus b, or maybe numerator is a minus b, denominator is a plus b. Then this is such a magical way to take out the value directly, okay, or the ratio directly. So what we will do, we will divide this two equation, and after dividing we will be getting x plus y by x minus y is equals to 6 by root 32, because root xy gone. And then we are using componendo and dividendo, and easily we are able to find the ratio which is given in the question, which we are supposed to prove. Clear?
Yes, ma'am.
Okay, so this is how we are proving it. Most of the scenario we have already discussed over here. Few more question I am showing you. Sometime your arithmetic mean and geometric mean based question will look like this. Just a moment, let me take it. I am taking a question related to geometric mean, but that can be also the same type of question can come from arithmetic mean. Just a moment, let me take it. Insert three numbers between 1 and 256 that the resulting sequence is in GP. Geometric mean concept we have discussed when we were supposed to introduce one number in between 1 and 256. If we are supposed to introduce just one number so that all three are in GP, then geometric mean. But three numbers, okay, three numbers, it says insert three numbers, okay, that means one is there, that means one is there, 256 is there, and you have to introduce 1 2 3 numbers in between so that all are maintaining GP. Still, if we are thinking about geometric mean, then we will be taking maybe the first three, and we will say the middle one will be the square root of the other the end numbers. But can you see two, both are not known, and this way we will end up puzzling everything. There is a easier way. If you will use the geometric mean concept which we are using till now in all the question, suppose I am saying this is x, this is y, this is z. So x is root 1 into y, right? Right.
Yes.
Okay, similarly now you will be taking the other three numbers, maybe like this, or maybe whatever way. Then you will be saying the middle one will be the square root of multiplication between the square root of other two. This way we will end up making everything puzzling. There is a easier way. So better not to use the geometric mean concept when you are having three numbers, four numbers, or maybe one, more than one number you have to introduce. Please use another way. What is the other way? We will be saying that suppose we are introducing g1, g2, g3, three numbers which are g1, g2, g3. It's not mandatory that you have to assume g1, g2, g3 only. You can take it a, b, c, x, y, z, whatever you want. Okay, you can take it. So we are supposed to insert three numbers. We have inserted this is our assumption. Now can you see this? We have a gp over here. Who said it is gp? Because it is written in the question that it is maintaining a gp, all maintaining gp. The resulting sequence is gp. So this 1 g1 g2 g3 is 256 is a geometric progression. Here can you see in this geometric progression, we know the first term a is 1. Can you see? And we know the fourth term. Okay, a4, 1 2 3 4 fifth, not 4, fifth term. Can you see? We know fifth term over here is 256. Yes or no? We have clarity at least about these two
Yeah.
terms. Okay. And if we will use the fifth term formula, that is nth term formula is a r to the power n minus 1. Okay. Fifth term formula is a r to the power 5 minus 1. That is 256. Can you see? We are able to find the r value from here. Why? Because a is known. Yes or no?
Yes, ma'am.
Again, law of exponent. This chapter is all about every time using law of exponent. Again, we need to use law of exponent. 256 you will be doing factorization, and you will be getting, I believe, 4 times 16, 16 into 16, yeah, so 4 to the power 4. So r is 4. When the exponents are same, the basis needs to be same, right?
Yes, ma'am.
Is it clear to all of you? Is it clear? Now we have to find G1, G2, G3. So G1 is the second term. G1 is the second term. Second term is A into R. G1 is the second term. That means AR. Okay. We have A. We have R. We can multiply to take out G1. What about G2? G2 is the third term. Third term formula is also AR to the power n minus 1. See, this is our third term. If you want to check, please check it. G1 is your second term, G2 is your third term, G3 is your fourth term. Okay, you all already know G1 can be written as AR, it can be written as AR square, it can be written as AR cube, and it can be written as AR to the power 4 by nth term formula. Okay, we have written the last term AR to the power 4, we got R. Now we have A, we have R. Can't we find G1, G2, G3? Can we? Yes or no?
Yes.
Okay, we have our A and we have our R. One more thing I want to tell you over here. Since the power was even number, whenever the power is even number, plus minus sign we need to take in consideration. It can be we are getting r to the power 4 is 256. So can we say r to the power 4 is equals to 4 to the power 4? Or maybe r to the power 4 is equals to minus 4 to the power 4? We can say that, right?
Yes, ma'am.
So there are two possible value of r. Hence, two different answers you will be getting, and it is completely fine in mathematics. Getting two possible answers is completely okay. Is it clear?